So here's a little reminder video for topic for review. I'm going to go through each of these problems and just remind you, give you some hints on how to get them started. So number one, we're supposed to find the value of y when x is a certain number, and they give us information about this being an inverse variation. So let me give it a color here. So when I think about inverse variation, we're thinking y equals not really sure what happened there. Okay, we'll try that again. I don't really want to restart the video. Okay, so we're thinking y equals k over x, and that's how we write an inverse variation, where k is our constant of proportionality. Our constant of proportionality. And that's how we started this chapter. Okay. That's how we started out this chapter, was we worked with this inverse variation. So remember, I'm going to plug in what I'm given, this x equals 2, y equals -4, and get my constant of proportionality. So when y is -4 and x is 2, I can solve for k. So I'll multiply both sides by 2 over 1. And we see that k is -8 because 2 times -4 is -8. So now I can rewrite, come on, negative, there we go. Now I can rewrite my equation, y equals -k over x. Sorry, -8 over x, k over x, but k is -8. And I can plug in 16 for x and solve for y. All right, so I do that for each one. So my constant of variation will be different for B and C. That's how you get that started. I'm going to go ahead and finish this. So when x is 16, y is -1/2. All right, so that's it on that problem. So there's two parts to the problem. First, you have to find the constant of proportionality, and then second, solve for the variable that's missing. All right, so number two, we're graphing rational functions, and we're going to graph when we get to the end. So I know the beginning says graph each rational function. So we're actually going to graph when we get through number 5. So now graph down here. I need to change that. All right, so we are going to find the x-intercepts first. So this whole section is just finding the x-intercepts. So remember, to find x-intercepts, I set the top equal to 0. Really what I'm doing is I'm plugging in 0 for y, but when I multiply by the denominator, it's gone. Okay. So I'm just going to remind you, our first step before we start this, our first step is to factor, right? We want to simplify first. So we're going to factor the top and the bottom, and honestly, that's going to help us as we move down. So I'm going to go ahead and factor a. So I have x minus 8 on the top, and numbers that multiply to be 14 and add to be 9 are 7 and 2. Now, I will need this further down in the question, so I'm just going to keep this here, and I'm going to plug in 0 for y and solve for x. So I know that x is 8, and we can keep that x-intercept at 8, 0, because we know x can't be -7 or -2, because that's what makes the denominator 0. All right, so we can keep that one. So remember, we want to factor and look for domain restrictions. All right, I'm going to continue with part A because it's the same equation. Now we're going to find the y-intercept. So to find the y-intercept for all three of these, I'm going to plug in 0 for x. So I go to my a equation, and remember f of x is just y, so y equals 0 minus 8 over 0 squared plus 9 times 0 plus 14. So notice plugging in 0 for x knocks out all of the x's, so I'm left with the numbers at the end. So negative 8 over 14 or negative 4 over 7 is my y-intercept. And I work all three of those that way. So now I have an x-intercept, I have a y-intercept. I'm getting closer to being able to graph. The next thing says find the vertical asymptote, so I'm going to set the denominator equal to 0. So you can see that this is where number 1 comes into play, that we've already factored that. So y equals x minus 8 over x plus 7 times x plus 2. So I'm going to go ahead and use the factored form. And I'm just going to set the bottom equal to 0 because vertical asymptotes help me figure out where the function's undefined. Well, setting the bottom equals to 0 helps me figure out where the function is undefined. And if we had a factor that canceled, that would actually be a whole. So I have two vertical asymptotes at -7, x equals -7, and x equals -2. Notice I wrote those as equations of lines, which is how you should write it, and those will be dashed vertical lines at -7 and -2 when I graph it. Alright, horizontal asymptotes. Remember, I do long division for this. So the bottom goes on the outside of the division. This is going to be a problem because there isn't anything I can multiply by x to get x squared, so that's 0. So y equals 0 is my horizontal asymptote. Alright, so I'm going to go ahead and sketch this down here. You guys will be doing this on your own paper, so you don't have to scrunch it. So I had a vertical asymptote at -7. It's not dashed. Sometimes my pen doesn't work, sometimes it works too well. Okay, here we go. Dashed at x equals -7 and dashed at x equals -2. So I'm pulling my vertical asymptotes from my list. I have a horizontal asymptote at 0, y equals 0. And then I have a x-intercept at 8. And I have a y-intercept at -4/7. Alright, so now we can graph this, and we can plug in a value over here. So remember, this splits my graph into 3 pieces. I have a graph in these 3 spaces. And so, since I don't have any x-intercepts over here, and my horizontal asymptote is at 0, I plug in a value, like -10. So -10 minus 8 over -10 plus 7. I'm plugging it into the factors because all I really care about is it negative. And -10 plus 2. So I end up with a negative on the top and 2 negatives on the bottom. That's going to make a negative. So it's below. And then I plug in something between -7 and -2, like -3. So -3 minus 8 over -3 plus 7 times -3 plus 2. So I end up with a negative on the top, positive here, and a negative there. That's 2 negatives, that's going to be positive. So I end up with a graph that looks something like that. And then I have to go through these, and it's going to go through my x-intercept and hover. Alright, so that's what my graph looks like. Again, you need to do that on your own paper. Alright, simplifying the product. Remember, we want to factor first. And then we can reduce top to bottom. Alright, so I want to factor first. My pen. Come on, pen. So I want numbers that multiply to be -12 and add to be 1. Multiply to be -6 and add to be -1. So factor those first. I can reduce factors top and bottom. On 7, I do need to factor first, but remember we're going to flip these over and change to multiplication, so it'll look like this instead of that. All right, so change it to multiplication, multiply by reciprocal. All right, on number 8, we need common denominators. So I look to see, okay, I don't have another one of these and I don't have another one of that. So I multiply them together for my new denominator. So there's the new denominator on the first fraction, and here's the new denominator on the second fraction. And I usually change this to an addition sign and put the sign on the number. And so then I look back to see what am I missing. So this was x plus 6, so I'm missing an x minus 1. So we multiplied by x minus 1 top and bottom. And then on this one I'm missing an x plus 6. So we have that on the bottom. I'm going to multiply by that on the top. And now I distribute, clean up, simplify. All right, number 9, find common denominators on the top and the bottom. Then you can switch it to a division problem. Number 10, make sure these are factored before we start. So I would take out greatest common factor of this one, and then treat it like an addition or subtraction problem. And you can figure out what's missing and make your denominators all the same, or you can clear the fraction. All right, that's my hints for you. See you soon.